Welcome back to the exam preparation video series for DP600, Implementing Analytics Solutions Using Microsoft Fabric. I'm Barbara Andrews, a Microsoft Technical Trainer. This is the third and final episode in this series. In this episode, we're going to focus on implementing and managing semantic models. We will also cover how to design and build semantic models and how to optimize enterprise-scale semantic models. Let's get started. Here is the detailed list of topics to know from this objective domain: implement and manage semantic models. As mentioned in the previous episodes, these are some of the skills you may or may not be tested on. Also, we will not necessarily cover every skill in this video that's listed here, but you need to be familiar with each skill before taking the exam. The list isn't exhaustive, but it's crucial for your exam prep. Let's begin. Choosing the correct model framework is crucial for optimizing performance, scalability, and our user experience in Power BI. You should review all the model frameworks listed here on the left. I'll give a high overview of each. First, we have import mode. This is ideal for smaller data sets where performance is critical. Then we have direct query. And this suits scenarios that require real-time data access and where the data set is too large to fit into memory. However, the best is that direct lake mode, which is best for analyzing very large data sets with real-time data updates and high performance. Be sure to review the best practices for the import mode, which includes things like always start with import mode if you can, only bring in the data you need, and avoid wide tables. Be sure also to review the best practices for the direct query mode. And they are things like limit the use of bidirectional filters on relationships, and also limit the complexity of our DAX calculations, and avoid the use of calculated columns, and also avoid relationships on calculated and unique identifier columns. Recall also the principles mentioned earlier for designing a star schema, as they will likely be on the exam. Remember that the preferred relationship is a many-to-one or a one-to-many relationship. Try to avoid the many-to-many or the one-to-one relationships, as they're usually very bad for performance. The example shown here is using Power BI to create a bridge table to avoid using that many-to-many relationship. This is a very common workaround. Recall too that using the bridge table in a star schema can deliver a number of benefits, one of which is your report visuals can filter or group any visible columns from the dimension tables, and another is that your report visual can summarize any visual column from the fact table. Filters are also applied to the order line and order date or product tables shown here, and they're going to apply to fact tables. And lastly, all relationships that are one-to-many and a regular relationship won't mask data integrity issues, and this is preferred. You may need to review DAX for the exam. Here are some specific functions to know listed here on this slide. What you want to do is review each function, what it does, and its syntax. Know also that DAX is a language for making calculations and queries in tools like the Analysis Services, Power BI, and Excel's Power Pivot. DAX uses formulas with functions, operators, and values to work with data in tables and columns to perform complex calculations. There are actually over 200 DAX functions. Review the functions that support filtering, windowing, and iteration. Recall that DAX variables can also be used in measures and allow for code readability and simplicity. Know the steps to implement calculation groups, dynamic strings, and field parameters, and the tools that they can be created with. New calculation groups can be created in Power BI Desktop using the model view and the Create New Calculation Group button in the ribbon. Also remember that you can define the calculation item in the formula bar and then add the calculation group to your visual, as shown here. Calculation groups can also be created in Tabular Editor too. Review how to create dynamic format strings on a measure. It is done by selecting it and then enabling the dynamic format in the ribbon as shown here. Then you write the DAX expression and verify that it works. Field parameters can be created in Power Query by selecting the desired fields. Once you have created a field parameter, you can then use it to control the measures or dimensions used in your visual. Review these steps and concepts and use cases for the exam. Large semantic models in Power BI Premium are designed to handle extensive data sets and provide optimized query performance. They store data in a highly compressed in-memory cache, enabling fast user interactivity, scalability, advanced analytics, and even incremental refresh. Once you have created a model in the Power BI desktop and you've published it to the Power BI service, you can configure the large semantic model setting as shown here on the slide. Remember that a composite model combines data from more than one direct query source, or it combines direct query with import data. Composite models allow you to use a hybrid table, which helps to strike the right balance between query performance and data freshness, and is essentially a large table that has one or more import mode partitions, as well as another partition in the direct query mode. You're going to want to review hybrid tables, their use cases, what they are, and what they do for the exam. I want you also to notice that the summarized aggregations are used here to improve query performance over very large direct query semantic models. And it's also cached data at the aggregate level in memory, which makes it really fast. This can be manually configured in the data model. Remember to view these design concepts for the exam. The Performance Analyzer in Power BI helps you to understand how each element of your report performs when users interact with it. In our example here on the slide, once you've started the recording, notice that Performance Analyzer captures the performance metrics of us navigating to a new report page, which shows up on the right as a changed page. We also changed a slicer and cross-highlighted a table noted here. All the interactions are in real time. Remember too that the visuals in the Power BI reports will trigger DAX queries, which get cached in memory. To ensure accurate results in the Performance Analyzer, remember to consider clearing the DAX query cache. This can be done by reopening the report or by using DAX Studio. Remember that DAX Studio is a powerful tool designed for writing, executing, and analyzing DAX queries in Power BI, Power Pivot for Excel, and even in the Analysis Services tabular models. It provides a dedicated environment for creating, testing, and optimizing DAX formulas, making it really an essential tool for anyone working with DAX. And you can use it to review the contents of your data model, view your model metrics, and write and optimize complex DAX formulas and queries. You can also view model metrics using the Veripax Analyzer, which is Power BI's underlying compression engine with an in-memory caching capability for fast performance and scalability. Remember to review the two engines too that make this up. One is the formula engine and the other is the storage engine. Note too the type of information that we can glean from it shown here. For the exam, note that direct lake mode is a semantic model capability for analyzing very large data volumes in Power BI. However, it is supported on Microsoft Premium and Microsoft Fabric SKUs only. Remember that if a DAX query on the direct lake model exceeds the limits of the SKU or uses features that don't support direct lake mode, like SQL views in a warehouse, and even queries can fall back on the direct mode if need be. Remember too to review the fallback behavior listed here. Please note too that by default, data changes in one lake are automatically reflected in the direct lake model. Incremental refresh is a feature designed to optimize the data refresh process by only loading new or updated data rather than refreshing the entire data set. It significantly improves performance and efficiency, especially for large data sets. Recall the features of incremental refresh and real-time data. They are fewer refresh cycles for fast-changing data when it's needed. Refreshes are faster, refreshes are more reliable, resource consumption is reduced, large semantic models are enabled, and setup is relatively easy. It's important to consider partitioning an incremental refresh to avoid loading data you don't need. Review how to implement incremental refresh by configuring parameters inside the Power Query editor and then setting up incremental refresh settings in both the Power BI desktop and in the Power BI service. To recap, in this episode, we discussed how to design and build semantic models and optimize enterprise-scale semantic models. Review these concepts, use cases, implementation, and licenses for the exam. Remember, too, that this group accounts for roughly 25 to 30% of the exam, so keep that in mind when preparing for the exam. Thank you for watching the DP600 Implementing Analytics Solution using Microsoft Fabric Exam Prep video series. We hope that this series helped you understand the skills that you're strong in and areas where you might want to revisit. Remember, too, that understanding all the concepts presented in this episode and in the 2 other episodes are crucial for your success. Be sure to leverage other exam prep resources such as the study guide, practice assessments, and the exam sandbox. All of these are available in the Microsoft DP600 exam website. Also on that site is a link to register for the exam when you're ready. On behalf of all of us at Microsoft, good luck to you and your exam. For more information, you can visit us at the URL shown here.